Welcome back, YouTube. If you're here for the more technical side of things, today is a video that you're definitely going to be interested in. Today I'm going to go over the Racepak Smartwire setup and show you guys a lot of the cool functions that thing is able to do and how I'm using them to control essentially every single component on my truck. If it's electrically controlled, I'm controlling it with only the Smartwire. So we're going to jump into that and show you guys why I think if you're wiring a race car, race truck, it doesn't even have to be diesel. Like, I want to put one of these on my dad's big block Mopar. This is the way to go, in my opinion. It can get pricey with all of the sensors that you're going to end up wanting to have, but there's really no system out there that I believe is as accurate and inclusive as what the Racepak setup does. So let's jump into that, and I'm going to show you guys on my computer here exactly what that looks like and how I control everything and how you make changes and the way that you can program logic into things to make sensor inputs control electrical outputs to everything on the vehicle. So let's jump in. Okay, so the first thing you're going to need to do the Racepak Smartwire setup is you're going to need obviously the Smartwire. You're going to need either the drag logger dash, the IQ3 dash. I would recommend calling Racepak, which is now owned by Holly, and talk to them about exactly what you're going to be doing. The setup that I have is the IQ3 drag logger dash, and I can go up to 18 channels on that dash before I have to add a V300 or a V500. So if you're 18 channels is a lot, but if you're gonna love data. Once you start getting data, you're just gonna want all the data you can get. So at some point, you're gonna run out of channels and you're gonna have to get a V300 or a V500. So it probably would be more cost effective to start off with that setup if you think you're gonna get 20 or 30 channels on your setup. So call Racepak, talk to them, and figure out what you're doing as far as that goes. Now, the second thing you're going to need is a basic laptop computer, something that is Windows compatible, so you can't use any sort of Apple product on it. It will not load the program. This is about the cheapest computer here you can get. It is an HP Pavilion. I think it was around 400 bucks, and it works totally great. I use this for just the race truck, so it's nice to have something specifically just for that. So once you get a laptop, you'll download the Racepak Datalink program software onto it. And once you do that, it'll walk you through how to set all that stuff up and whatnot. And then once you've got that set up, you'll open the Datalink program. And this is what's called your config page. So it might be a little hard for me to film this. I will do my best, but I'll read them off to you. So essentially everything on your left here is going to start with whatever sensors you have. So in my case, I have about 13 sensors right now, and all of your sensors are going to be over here on the left. And then when you get into this SM section here, that is all of your outputs. You get 30 power outputs on a Smartwire. A Smartwire will not send a ground output, but it will send a power output. So like on the 4748 stuff, how you would commonly command overdrive and lockup is you would basically send 12 volt power to the number 1 pin, and then you would ground out the pins for overdrive and lockup. So essentially how we do it with the Smartwire is the opposite. We just send, we go ahead and ground the solenoids, and then we send power to, each one. So essentially we would go in the valve body and we would ground the one side of, the solenoid to the valve body, ground the other, and then power the other side with the Smartwire. So basically you're just reversing the polarity. And then the only other thing that the Smartwire won't do that I really wish it would do is it won't PWM, it won't pulse width modulate. So you can't really run it as a nitrous controller unless you're just cool with turning your solenoids on. So it works perfect for spool jets, but when you get real serious into nitrous, you'll still need to add a nitrous controller for the most part. So, like I said, these are my sensors. So essentially I have engine RPM, drive shaft RPM, water temperature, oil pressure, battery voltage comes with it. It's built into the logger. And then some things I'm logging, trans brake, and then I have a pan vac sensor, AFR, boost pressure, fuel pump pressure, trans temp, EGT, wheel speed, aka drive shaft, transmission pressure, nitrous bottle pressure, Excel G, and lateral G. So Excel G would be the G-force, you know, going down track, going straight, and then lateral G would be left to right G. On some Trick Pro mod stuff, they use lateral G to automatically deploy parachutes if the car gets too out of hand sideways, but really I don't need that. It's made into the G meter, so you get it regardless if you need it or not. And then from this point on, it starts all of the power outputs as to what I'm, you know, powering the truck. So my water injection, the dump valve, the starter, the water pump, my trans brake, both of my fans, my staging limiter, lights, intercooler pump. I have my all of my nitrous kits are powered by this because I'm not PWMing them in. I have a spool jet, both spool jets on it, the shifter, overdrive, dump valve. Essentially every single thing that needs to get power is being power sent from the Smartwire here. So I'm just going to open up starter to start with and show you guys what this looks like. So over here you have your fuse current, and essentially what that is that's like when you want it to blow a fuse. Basically, do you want it at 20 amps, do you want it at 30 amps? You can go between 0.5 and 30 amps on all of these as far as the fuse current goes. Now, as far as the way the Smartwire is wired, you only have 10, 20 amp outputs, and then the rest are all 10 amp. So if you run out of your 20 amp outputs, say you use all 10, and you need more than that, you'll have to tie two 10 amps together. So basically, I'll show you how to do that because that's how I had to do a couple of my nitrous solenoids. So I'll show you that when we get there. And then, you know, basically you have a max voltage that you can change this to. And then the retries down here is basically, as soon as it blows the fuse, essentially, it will try to basically repower it. And then you can change the number of times that you want it to try that. So if you only want it to, hey, as soon as it blows once, kick it off, it'll do that. If you want it to keep trying, because maybe it was a fluke, it'll keep trying whatever this number is here. Most of this stuff is already preset pretty good. It comes with, when you buy the Smartwire, everything is pre-labeled as far as the wiring goes. And some of the simple stuff like starter, water pump, trans brake, all that stuff is already pre-programmed here for you, so there's really not much you have to do here. And then over on this side, this is going to be your VNet ID. So when you get into using a sensor to control an output, this is where it'll say like engine RPM or wheel speed or something over here on the right. And then you can change the output function. I'll show you that. So right now it's constant on. So that means that once it gets commanded power to it, the power just stays constant to it. You can put it on a flash mode, so basically it'll act like a turn signal. And then you can put a latch on to where once it gets power, it'll stay with the power on. Even if the Smartwire tells it to turn off, it's going to be latched on. It will not turn off. I haven't found any reason to use that yet, but maybe there's something down the line. And then single pulse would be it just hits it one time with power. So also haven't found anything that I would need that for yet, but it's nice to have, you know, settings like this in case you find a way that you want to manipulate the system. And then logger sample rate. So this is just basically if you want to log in your actual data log, if like this is starter, so there's no reason that you would ever want to log starter in your data log, so it's disabled. And if you wanted to turn that on, like I don't even think this one won't even give you a option to do it because it's starter, but some of the other ones it'll just be like enable logging, and then it'll show up on your log, and I'll show you a log towards the end here on that. So that's essentially all your programming that you have here that you really need to worry about if you're a beginner to this. So if you go here to on condition, this is going to be where you'll program the logic. So basically what I mean by logic is whatever conditions need to be met for this to send the power output. So over here is where you'll scroll through, and all of your, like everything, this comes with a switch panel too. So all of your switches on the switch panel, all of your inputs from the Racepak stuff, it's all on there. And so you can use any of these, anything in this left box, you can use to control an output. So you can see here, there's tons and tons of possibilities of what you can control. Obviously, on the starter, it has one job, and it just needs to start. So on the switches here, the switch panel is every switch you can go through and you can label them all. And basically, SP1 starter is the #1 switch on the switch panel, and that's your starter button. So you'll basically select that like it is. And then over here is your operation. So equal to 1 means that the switch is on. So it's either the switch is on or the switch is off. And then not equal to 1 would mean that it would send power to the starter anytime that switch was not on. So that's not the one you want. You want the one that's only going to send power to the starter when the switch is on. I can already tell you guys, this is going to be a long video. I apologize if you hate long videos, but this is really good information that I think everybody needs to at least know about. So equal to 1 is the one that we're going to use, and I'll show you some of the other examples as we move on what other conditions you would use and why. But basically this means, and then you'll right click it over here in this box, and then that will put it in the logic box. It doesn't matter what's set over here. You have to make sure that the logic is over here. As long as whatever it says over here is right, this is what you're going to program the Smartwire with. You could have all of this stuff filled out, but as long as it's not over here in the logic box, it doesn't matter. So, all right, so we have that condition. So basically, as long as the starter button is equal to 1, this thing's going to start. Now, on my truck, I have a remote start button out on the engine, so that way I can crank the truck over when I do valves and stuff like that, or when I need to start it on ether by myself, I can do that. So I just go over here, and I have an auxiliary input that is basically wired to my remote start. And I go over here and I click on that, and you'll see where inputs come up, and you'll click on remote start because that's where I have that already programmed. And I will click on that and put that in this box here. And then same thing on this, we're doing equal to 1 because we only want the starter on when I hit that button. So now it says that if I hit the starter button on the switch panel, it'll start the truck. If I hit the starter button on the remote start, it'll start the truck. But as soon as I let go of both of those, it quits. So that's exactly how you want that to be. So now you would just hit OK. And then you will want to send config. I'm not hooked up to the truck, so it's going to send me an error message. But after you hit send config, a little loading thing will come across the top here, and it'll say message sent correctly, something like that. And then you know that you're good. And every time you make a change in the Smartwire, you want to hit OK, and then you want to go over here. So you want to hit File, and then you want to save. Every time you make a change. If you don't do this and you forget to do this, the logic will still be in there, but it won't save it to the screen. So the next time you pull it up, your changes won't be the same and you'll be really lost. And I know this because I've done it several times. So that is really all it takes to programming the logic in this thing. So let's talk about something that is a little bit more complex that needs some more work. So let's go. I'm trying to think what I have turned on. Okay, spool 2. We'll click on that one. I'll show you guys that one. So we'll go, it's a constant on, nothing really special here. The max fuse amp current on this one is 15 amps. So this is a 10 amp one. Now this is one of those ones I told you about where I tied them together. So essentially this is, I'm sorry, this is not one of those. One of the down tracks are the one that I tied together. The small spool jets are only 10 amp, so you can get away with just running a 10 amp current. And then I always just set these up to 15 amp on the fuse current, so that way it's higher than the amp, because what I found on a nitro solenoid is sometimes if you set this at 10 amps, it'll draw 11 amps like right on the initial hit, and then it'll kick it off. So you just want to set this up a little bit higher so you don't run into that problem. So we'll go to the on condition on this one. Okay, so engine RPM. So I have the sensor input. So this is an actual Racepak sensor that I have that is in the logger. Engine RPM, and I have it at greater than or equal to 1900. So that means that the engine RPM has to be at least or above 1900 engine RPM for this nitro solenoid to turn on. And then the way I turn this nitro solenoid off is this one I'm turning off or is this one I'm leaving on? Let's see. Boost pressure, which is another input I have, has to be less than or equal to 14. So what that means is if the boost is 14 or less, then the nitro solenoid is on. So you see over here in the logic, engine RPM greater than or equal to 1900, boost pressure less than or equal to 14. So this means that as soon as the engine hits 1900 RPM, it turns this nitrous kit on. And as soon as boost gets above 14 PSI, it turns this nitrous kit off. So you can go through and you can make that do whatever you want. You can leave it on. You can use anything over in this left box to control on and off on any of your electrical outputs. So you have a ton of options there. And then the nice thing is, so like why this says SW number 8 equal to 1, this is over here because when I'm setting up the nitro setup, I'm testing it with a switch on the switch panel. So if I wanted to test this with a switch on the switch panel, I would just come over here and put that back in. And now it'll still do engine RPM and boost, it'll still control it that way, but now it'll also control it if I turn this switch on the switch panel for testing purposes. So I do not want to do that, so we're going to remove it. And then, like I said, always remember to send config, okay, and then file and save. And then one thing I want to show you as far as this start live channel data is like the most useful tool you'll ever have. It won't work right now, obviously, because I'm not plugged into the truck, but yeah, it says it cannot open. But basically, when you click on that, it'll show voltage and status. So status would be like if it's on or off, and then it'll show the voltage. So when you're checking to make sure something is getting power, or if you're trying to troubleshoot, you can start live channel data, and then the status will be off and it'll say 0 volts. And then when you turn it on, it'll say whatever volts your battery is. So like in mine, a fully charged battery, it'll be 13.4 volts. You know that the Smartwire, you've got it programmed correctly to sending the power output. So that's a really helpful tool for troubleshooting. Okay, so let's look at one of these downtrack nitro solenoids that I had to tie two together, and I'll show you how I programmed it when I tied two together. So this is Nitrous Kit 1A, and I'll explain the A here in a second. So This is pin number A7. So on the Smartwire, the two connectors are A and B connector, and then each pin is assigned a number. So A7 is this particular pin. So the reason that this is N2O kit 1A is because I tied two kits together, or two pins together, to make this one nitrous kit. So I tied A7 and A17 together. So that means that every time that you make a logic change in this, you have to do it to both. So A7 and A17 need the same logic change done. So that's why this is N2O kit 1B. So on the on condition over here, you'll see, so I have trans brake not equal to 1. So that means that anytime the trans brake is not applied, the nitrous would be on. And then the other condition is that the boost pressure must be greater than or equal to 15 psi. So essentially that means that if the engine makes less than 15 pounds of boost and the trans brake is off, it will not turn on the nitrous kit. But if the boost is over 15 psi and you're not on the trans brake, it will turn this nitrous kit on. So that is So that is A17. So now you have to go to kit 1A, which is A7, and you have to make sure that that logic is exactly the same. It has to be trans brake not equal to 1 and boost pressure greater than or equal to 15. So if that's different, if this is boost pressure greater than or equal to 10 or something different with the trans brake, this solenoid won't work because this solenoid requires 20 amps of power and each pinout is only 10 amps. So even though the logic is applied correctly to 1, it won't send enough power to the nitrous solenoid to turn it on. So any change, if you're tying two together, you have to make sure that you label it very specifically, and anytime you make a change to one, you have to make a change to the other one. And then, so like shifter, here's a good one. So shifter is the same deal. Go to the on condition on this. Now this is where you kind of, like some of this stuff you have to do some thinking about, and you really have to think. I tell people anytime you're doing anything with the Smartwire, like turn off all your distractions, tell your friends to give you a minute, because you can change one of these logic things wrong and you can really screw a lot of stuff up. And you can actually, you know, it's an amazing tool, but you have to be careful because like any tuning tool, you can hurt stuff if you don't pay attention to what you're doing. So this is, first one here is engine RPM greater than equal to 4,600. And then you have to make sure the true condition and the false condition match, or otherwise it won't let you put the logic over here. True and false conditions are like way beyond anything that I have found the need to do yet. So just make these two match. And then true delay would mean essentially that this would have to see 4,600 engine RPM, and then if you put a 0.5, that would be a half a second delay in it. Once it sees 4,600 engine RPM, it would wait a half a second, and then it would turn on. And then a false delay would be that once it dropped below 4,600, if you put a half a second in here, it would take a half a second before. So there's some times when you would want to use a true delay, like on a dump valve, if you were wanting to leave it on. When you left the starting line, you would put a true delay on trans brake and you would leave it on for a timed amount. But we don't want to do that here. So engine RPM has to be greater than 4,600. But then this is the important part if you're using RPM to shift. And same for drive shaft RPM. The engine RPM needs to be less than 4,650. So the reason that you want engine RPM above 4,600 and less than 4,650 is so that way it sends the power to the shifter solenoid once it reaches above 4,600, but then it turns the power off after it hits 4,650. And the reason that this is important is because if you make a shift, and this has happened to me several times, and the RPM doesn't drag down far enough, because you have to keep in mind that you're leading these shifts. This 4600, when I'm commanding this power output at 4600, it's actually making that shift at 5000 RPM. So at 5000 RPM, there's situations where it won't drag the RPM back down below 4600. So if it doesn't drag the engine RPM down below 4600, it won't turn the power off to the solenoid. And so what'll happen is your shifter will get stuck in gear because it needs the power released from the solenoid to release the air to get it ready for the next shift. So you'll have a truck that'll make the 1-2 shift, and then it'll go out there and it won't make the 2-3 because it never dropped below 4600 engine RPM. So that top line needs to be greater than 4600, less than 4650. And then to make the next shift, that's your 1-2. So then to make your 2-3, if you're doing engine RPM, you have to do it at a different shift point, technically. So I have the 2-3 coming on at engine RPM greater than or equal to 4700, and then off at 4750, and that'll make the 2-3 shift happen around 5100-ish RPM, because it's about 100 RPM higher leading it than this one is. So that's a really important, regardless if you're shifting on engine RPM or if you're shifting on drive shaft RPM. And then if you're shifting on time, that's a totally different deal. I don't personally like shifting on time, so we're not going to get into that. Another one I'll show you here real quick is, where is the water injection? No, not water injection, because that's set up just like nitrous. Intercooler pump. So on the diesel stuff, you don't really want your intercooler pump on while you're trying to spool, if you have an air-to-water intercooler like I do, because that cold air will actually make it harder to spool. So I want my intercooler off until it's, I have it set up right now to where the boost pressure is greater than equal to 12. So once my boost gets above 12 PSI, that's when I turn my water pump on for my intercooler. The reason that I choose 12 PSI is because from what I have found, when the turbo gets to 12 PSI, that's when it's rocking and rolling, and from 12 it'll make whatever boost you want it to make at that point. The struggle is always getting it, really the struggle is from 0 to 7, and then from 7 to 12 is where you're hitting up against the converter. So once you get it over 12 PSI, I am past, in my opinion, spool up. So now I want my intercooler on, so that way it's on for enough time before I take off to actually do something to actually chill the water down. If you don't turn the intercooler pump on until you leave the starting line, you'll never get the intercooler cool enough to do anything, and it'll basically just become a heat sink. It won't really work well as an intercooler for you. So that's a pretty good overview on how to program your Smartwire. So now what I'm going to show you is I'm going to show you a data log, and I'm going to show you how you can look at all of this stuff. I'm not going to get into how to read a data log or any of that stuff in this one, but I will show you, oops, I don't want a new data log, but I will show you what a log looks like and what you're able to look at with those. Okay, so when you pull up a log, the engine RPM is automatically going to populate. To turn any of these on to look at, you basically will just right click, my bad, you'll left click. So if you wanted to look at boost, you would left click on boost, and then you'll see it's red. So to make it a different color, you just left click it again, and then left click, and then boom, it's a different color. If you don't like green, you make it blue. If you don't like blue, you make it yellow. You get where I'm going with this. I am a freak, and my boost has to be green. Engine RPM has to be red, boost has to be green. No reason to it, just I'm weird. So this is wherever you have your logger set to start logging, which mine, it starts logging at 2 pounds of boost. I don't have any reason to log anything anytime other than when it's starting to get up on boost. So The time is over here on your left at the bottom, so 0, 2, 4, 6, all that stuff. So anytime you're doing a log that you're interested in the time on, I go until it starts logging, and then I click this little green T, which is time, and then I hit OK, and then that changes the time. So now if I'm wanting to see how long it took me to spool, I know that this is when the logger turned on. So logger turned on at 2.8 pounds of boost on this. And then it was up on the limiter by there 21 pounds of boost in 3 seconds. So it took me 3 seconds to get from 2 PSI to where I want. Okay, so then if you want to look at like your wheel speed, you just come over, which this is drive shaft RPM. You come over here, click on it. Obviously, because this was a spool up, it's just a flat line at the bottom. You can't even see it here. So that's not really going to be useful information for you. If you want to, and then just left click it to get rid of it. So if you don't want to look at boost anymore, you can turn that off. Ooh, gotta get back to that green, remember? So, oh, look what I've done now. So okay, so if you want to come over here and look at EGT to compare it to boost or to engine RPM, you just left click on EGT. That pulls your EGT up. So any sensor that you have, any Racepak sensor, is logging capable, and you can use any one of those. You can look at bottle pressure, you can look at XLG, you can look at trans pressure, you can make this graph to where you can't even read it because you don't know what the heck you're looking at with all this stuff. But any sensor you have, you can read on a data log. So like I said, I'm not going to get into reading data logs in this one, but I just wanted to show you the capability of the Smartwire so you had an idea of what I'm talking about when I'm talking about inputs and outputs and all of that good jazz. Alright, so before I cut this video off, let me just explain a couple little things a little bit more about the Smartwire. The Smartwire is a PDM, which means a power distribution module. It's also technically a PLC, so if any of you guys are familiar with what PLCs are, it's just everything I've been telling you. It's just you're using a sensor input to control an electrical output via logic. That's all a PLC is. So you can run the Smartwire alone by itself with no other Racepak stuff, but if you do that, it just basically becomes a fuse box that you can program a little bit of logic into. You're not going to be able to do any of the trick output stuff that I just showed you because you need the logging capability and you need the Racepak sensor inputs to be able to read parameters of what the engine, what the transmission, what the drive shaft's doing to control an electrical output. So if you do want to use it to its full capabilities, you will have to buy the Racepak logger dash setup and the Racepak sensors. I will tell you that Low Dollar Motorsports sells some more affordable sensors. They don't sell nearly all the sensors that Racepak has, but they do sell a lot of sensors that are compatible with the Racepak that are a lot cheaper than the Racepak stuff. That's the biggest downfall of the Racepak is honestly the cost. The Smartwire setup alone with the switch panel and all the wiring needed is about $2,300 or $2,400 right now, which sounds like a lot of money, but man, if you go through and you add up what it takes to wire a car, a fuse box, the wire, all of the relays that you would have to run all this, you start to realize pretty quick that it's really not that much, if not any more money, than trying to piece it all together and you ultimately have something that you can't program any logic with. The Racepak logger dash setup is going to set you back about $1,800. Comes with 3 or 4 sensors to start with. So entry level to get into this with just a couple basic sensors, you're talking around $4,500, $5,000, depending on how many sensors you want to get. If you want to get a decent amount of sensors, a lot of the sensors like I have, I would budget about $10,000 for it. That's a huge number. That's a big, scary number when you're talking about things that seemingly don't make your vehicle any faster. But I promise you, good data is as valuable, if not more valuable, than spending $10,000 on your engine. You can take a combo that is seemingly uncompetitive, and with good data, you can really learn how to optimize your combo and make that thing run good, and that $10,000 is well worth it. You can also set up safeties to where you're not worried about blowing up turbos. You can monitor shaft speed. There's just endless opportunities when you have good data logs. And when you have a good data logging system, every race car guy in the world knows Racepak. You can send your logs to guys that, you know, have been doing this for 10, 15 years, and they can say, hey, you know, this is what I see here, this is what I see here. It is honestly be well worth the 10,000, and its value beyond the cost of it. So I don't sell Racepak stuff. This isn't like a sales pitch or anything. I just really love their products. I've had great success with it. I love being able to control everything on my truck with one unit, and I just think that there's a lot of people that could really benefit from it, and I just wanted to put the information out there for you guys and show you kind of how I do it. So I appreciate you sticking with me through this one. I know it's a little bit long, but hopefully you guys will find it worth it. And like always, I appreciate it, and we will catch you on the next one.